Good morning, student. This is chapter number 14. This is the last chapter, Semiconductor Electronics, Metals, Devices and Simple Circuits. Right? So this is the last lecture, lecture number 5, Optoelectronic Devices. Right? Opto means related to the light. Right? And electronic devices. So these devices are related to the light. Right? Now there are three types of optoelectronic devices as per the syllabus of class 12 physics. In these devices, the charge carrier are generated by the photons, right? So it is known as photo excitation. Whenever the light falls on these devices, the charge carriers generated and produce the current in the circuit. Now we will study the following devices. Number 1, LED, light emitting diodes. Number 2, photodiodes or photodetector. And number 3, photovoltaic devices means solar cell. So we have to discuss these three devices. Now first of all, light emitting diode. So in this case, the LED is connected with the supply, power supply, means battery. So what happens, this diode emits the light. Light means the visible portion of the electromagnetic wave. So it is called LED. So it is the heavily doped PN junction diode which emit visible light in forward biasing. When LED is placed in forward biasing, majority charge carriers are pushed towards the PN junction. At the junction, electron hole recombines and the process energy is radiated in the portion of visible light. Actually, what happens in case of PN diode, this is the PN diode, there is a potential barrier at this junction. When the holes of P type and electrons of N type, when it becomes forward biased, so what happens, these majority charge carrier pushed towards the junction, means these majority charge carriers are coming towards the junction. So these charge particles gain some kinetic energy, and this kinetic energy is gained by the charge particle at the cost of work done by the battery, means the work done by the battery is converting into the kinetic energy. When these holes and electrons recombine, so their kinetic energy becomes zero, since the vacancy filled by the electron. Now electron is not moving after the recombination. It means kinetic energy becomes zero. So this kinetic energy converted into the light energy, and this diode starts emitting light, right? So this is called light emitting diode. Again, once again, light means visible light. So we can see there are so many types of LED of different colors, red, green, violet, means the colors of visible light. So this is the graph in which we are forward biasing it. This is the forward voltage, this is the forward current. So this is the current related to the different color of LED. Now this is the photodiode. Now this photodiode is reverse biased, right? So what happens when the PN junction diode designed to work in reverse bias to detect the light intensity of light? When light falls in it, it will produce the majority charge carrier, it increases the majority charge carrier as well as minority charge carrier. And what happens? There will be the larger current, right? Now working. In reverse biasing, the electrons and holes are pulled away from the junction due to the depletion layer, and depletion layer becomes thick. When light of suitable frequency falls on the depletion layer, but that light should be greater than the band gap, the electron hole pairs are created. So the current flow in the circuit. This reverse current is directly proportional to intensity of incident radiation, right? So it means whenever the intensity increases, the number of photons are increasing. If number of photons are increasing, the number of hole electron pair increases. So what happens? The current in the circuit increases. Now, since it is reverse biasing, so this is the reverse voltage, and along the y-axis there is reverse current. So after increasing the reverse voltage, the current initially increases, and after fixed value of voltage, the current becomes saturated, means becomes constant. So what is happening over here? This is the diode. This is P type. This is N type. Holes are majority charge carrier in this section. At N type, there are majority charge carrier electrons, right? Due to the presence of battery, it becomes reverse bias. It means holes are coming towards left, towards the negative terminal, and electrons are moving towards the positive terminal. So there will be no current. But when light incident on the junction, the hole and electrons are generated in both the sections, right? In both the sections. Now the hole of P type is moving away from the depletion layer, and inside in the N section, electrons are moving towards the right, means positive terminal. But the minority charge carrier are pulling towards the junction, and they are easily cross the junction. So there will be the current. If the intensity of photon increases, means number of photons are increasing, the number of electron hole pairs will increase, number of minority charge carrier will increase, and hence the current in the circuit will increase. It means the current or the reverse current in the circuit is directly proportional to intensity of light, incident light. So we can detect the light from this diode. So it is called photodetector or photodiode. The symbol is a diode and the photon are incidenting on it. So we can make the symbol of this type of diode is this is diode, normal diode, PN diode, and light is incident on this. So we have to draw arrows towards the PN. Right? So this is the symbol of photodiode. Now the solar cell. It is the PN junction diode which generate EMF when solar radiation falls on it. Solar radiation means electromagnetic wave is falling at the PN junction diode, so that is solar cell. But the solar cell is different from other PN diodes. It consists of very thin layer of N-type semiconductor with thin finger metallic electrodes on the surface and thicker P-type semiconductor. It means P-type is thicker and N-type is thin, right? In normal diode, what happens? The thickness of both the section will same, P-type and N-type. But in solar cell, N-type is having the smaller thickness. When solar light falls on the finger electrodes side of the surface, they reaches at the junction. Actually, what is our purpose? Our purpose is to send the solar light at the junction. For that, we make N-type very thin. EMF is generated due to the following three processes. What happens? Number one, when the light reaches at the junction, the electron hole pair will generated at the junction. Number two, separation. Due to electric field of the depletion layer, electrons move towards the N-type and holes move towards the P-type. Now the collection. Last one is collection. The electrons and holes are collected by the contact diode. So potential difference is set up between them. It means it is acting as a cell. When it is placed in the closed circuit, the current flows. Right? Now we can see this is the picture of the diagram of the solar cell. Now you can see there is finger like metallic structure. Right? This is N-type and this is P-type. The light can reach at the junction. Light means solar radiation reaches at the junction. Now we can also discuss this graph. This is the voltage, right? Forward voltage. And this is the current, reverse current. When the current is zero, it means circuit is open. No current is flowing across the circuit. When the voltage is zero, current is maximum. It means it is short circuit. Without voltage, we are getting the current. Right? So this is the circuit of the solar cell. And this is the symbol of solar cell. Right? So this PN diode have different structure than the other diodes. This is the larger line, longer line, this is the shorter line, and this is photon. Means the solar radiation are incident at this device. So this is all about the optoelectronic devices. Thank you very much.